Hello students and welcome to my channel Maths App. So today in this video I'll tell you how to trace the Folium of Descartes. So if you haven't watched my previous videos on the preliminary requisites for tracing a curve, do watch them. It will really benefit you. And I have also traced one curve. So do check that video also. So now let's see how to trace the curve x cube plus y cube equal to 3axy. So this curve is also known as Folium of Descartes. This is a very famous curve. And now let's see how do we trace this curve, right? So before we begin tracing this curve, we have to check in these 4 points: symmetry, origin, asymptote, and points of intersection. So these 4 points are of great help to trace any curve. So let's talk about symmetry first. So under symmetry, you have seen that we can check symmetry about x-axis, y-axis, origin, symmetry about both x-axis and y-axis, symmetry about y equal to x line, and symmetry about y equal to minus x line. So you can see that the curve doesn't contain any even powers of x or even powers of y. So it will neither be symmetric about x-axis nor it will be symmetric about the y-axis. Now to check symmetry about origin, we have to replace x with minus x and y with minus y. So you will see that the left hand side will have a negative sign, but the right hand side will not have a negative sign. It will have a positive sign. So it will not be symmetric about the origin. Now, if I replace y with x and x with y, you will get the same curve, isn't it? So that means this given curve is symmetric about y equal to x, right? So the first point is covered. Now let us check origin. Will the curve pass through the origin? So you can see here that there is no independent constant term present in this curve, and hence this curve will definitely pass through the origin, right? So if it passes through the origin, so we will have the point 0, 0. So now we can calculate tangent at this point, tangent at the point 0, 0. So we can calculate tangent by putting the lowest degree term equal to 0. So when we put x into y equal to 0, we will get two equations, x equal to 0 and y equal to 0. So we are getting two real and distinct tangents. So the point 0, 0 acts as a node, right? So it's a double point. The curve will pass through this point two times, right? So after origin, let us try to check asymptote. So you have to take care of the point SOAP. So how to calculate asymptote? Rectangular asymptotes are calculated by putting the highest coefficient of x and highest coefficient of y equal to 0. So this will not give you anything. So there is no rectangular asymptote. Let us try to figure out if we have some oblique asymptote. So let us put y is equal to mx plus c. So we have x cube plus, I'm directly writing the equation, m cube x cube plus c cube plus 3mx into c square plus 3m square x square c is equal to 3ax into mx plus c. So let us rearrange the terms. We will get x cube plus m cube x cube plus c cube plus 3mc square x plus 3m square c x square minus 3am x square minus 3acx is equal to 0. So let us equate the highest coefficient of x, that is 1 plus m cube equal to 0, and let us equate the highest coefficient of x square equal to 0. So that will give us 3m squared c minus 3am is equal to 0. So if m cube is equal to minus 1, so the only real value of m that we will get is minus 1. So let's substitute here. So we will get 3c minus 3a, m is minus 1, so that will make it plus. So is equal to 0. So c is nothing but minus a. So the equation that we will get is y is equal to minus x minus a. So that means x plus y is equal to minus a is the equation of the asymptote, oblique asymptote, right? So this is our oblique asymptote. So you need to take care of the points that we are getting. They will help us to sketch the curve. So it is symmetric about y equal to x line. It is passing through the origin. The point origin is acting as the node, and there was no rectangular asymptote, but there is an oblique asymptote, x plus y is equal to minus a, right? So we have covered SOA. Now let us try to cover up P, points of intersection. So for points of intersection, what we can do is we can substitute y equal to 0 and check, do we get any point of x. So when we put y is equal to 0, it will give us x equal to 0, right? And similarly, when we put x equal to 0, it will give us y equal to 0, right? So origin is the only point of intersection. So the curve was symmetric about y equal to x line. So we can see that whether there is any point of intersection on this line x equal to y. So let us substitute x cube plus x cube is equal to 3ax square. So 2x cube is equal to 3ax square. So we can take out x square common. So we will be left with x minus 3a by 2 is equal to 0. So x is equal to 0 and x is equal to 3a by 2. So another point of intersection that we will get is 3a by 2 comma 3a by 2. Right? So now we can also calculate tangent at this point. Do we have any tangent at this point? So let us shift our origin to this point, x plus 3a by 2 and y is equal to y plus 3a by 2, right? So let us substitute. So we will get x plus 3a by 2 whole cube plus y plus 3a by 2 whole cube is equal to 3 into a into x plus 3a by 2 y plus 3a by 2, right? So we get x cube plus 27a cube by 8 plus 3, I'll just write the term here, 3 into x into 9a square by 4. So that will give us 27x a square by 4 plus the next term would be 3 into x square into 3a by 2. So that would be 9ax square by 2, right? Plus we'll get y cube plus 27a cube by 8 plus 27a square y by 4 plus 9a y square by 2 minus, now let's take these terms on the right hand side and I can check these two terms as, I'll just simplify it here and we will bring the terms on the left side, right? So this bracket term is basically x into y plus 3ax by 2 plus 3ay by 2 plus 9a square by 4. Let's multiply it with 3a and bring it on the left hand side. So we will get 3axy minus 3 into 3 is 9, a square x by 2 minus 9a square y by 2 minus 27a cube by 4 is equal to 0. So this is our equation, right? So here we can see that 27a cubed by 8 will get cancelled, right? Then it's any other term getting cancelled? I don't think so. So now from here, to calculate the tangent, we have to equate the lowest degree term equal to 0. So what is my lowest degree term? This is one term. 27a square by 4x. Then this is x square, this is y cube, this is y, yes. 27a square by 4y. Then we have minus 9a square x by 2 minus 9a square y by 2 is equal to 0, right? So let us solve this. So we will get 27 by 4 minus 9 by 2. So 4 is the LCM. 27, this is 18. So we will get 9 by 4, right? So we get the equation 9 by 4 a square x plus 9 by 4 a square y is equal to 0. So if I multiply with 4 by 9 by a square on both sides, we will get x plus y is equal to 0, right? So get back the equation of the tangent. Let us substitute capital X as x minus 3a by 2 and y as y minus 3a by 2 is equal to 0. So we will basically get x plus y is equal to 3a. So this is the equation of the tangent, right? So this is the equation of the, right? Okay. So this is that what we are getting from points of intersection. Now, another thing, the curve is x cube plus y cube is equal to 3xy. To check in which quadrant this curve cannot lie, right? You can see that if we put both x and y negative, right, it will have minus x cube minus y cube and this will become a positive. So the equation is not supporting each other. That means the curve will never lie on the third quadrant. Curve does not lie in the third quadrant, right? So with the help of all these points, let us try to cover up or trace the curve. So equation of tangent is x plus y is equal to 3a. The equation of the asymptote was x plus y is equal to minus a. The curve was passing through the origin. The points of intersection are 0, 0, 3a by 2 and 3a by 2. And similarly, we also saw that 0, 0 is a node, right? So based on all these things, let us try to trace this curve. Okay. So first of all, let us try to trace the line x plus y is equal to minus a. This is the asymptote, right? So how do you mark an equation? Let's try to make a table checking the points and then we will make this line. So let's put x equal to 0. We will get y is equal to minus a. Now let's put y is equal to 0. We will get x is equal to minus a, right? Okay. And you can similarly put x as a. So if I put x as a here, y will become minus 2a. And if I put y is equal to minus a over here, I will get, okay, this would be the same point. So let me put y is equal to a. So I will get minus 2a, right? So these are my points. So 0 comma minus a is here. Then minus a comma 0 is here. Then a comma minus 2a would be somewhere here. And a comma minus 2a comma a would be somewhere here. So I'll get this as my asymptote. So I'm trying to draw a straight line. So you will always take the help of a ruler to draw the straight line, right? Yes. So this is the line x plus y is equal to minus a. So this is my asymptote, right? And what will the asymptote help us to know? That the curve will not cross this line, right? Okay. Then 0, comma 0 is the point of node, right? The curve was also symmetric about y equal to x line. So I can draw y equal to x line like this. So this is my line y is equal to x. So one point of intersection was origin. So I'm not writing this origin because you already know that this is the origin. And then we had another point of intersection as 3a by 2 and 3a by 2, right? Okay. And we also knew that there was a tangent at x plus y is equal to 3a. So let's try to draw x plus y is equal to 3a. So put x equal to 0, y will become 3a. Put y is equal to 0, you will get x is equal to 3a, right? So if 3a is somewhere here, and if I put x as 3a by 2, then y will also be 3a by 2. That means uh, the equation, the tangent will be somewhere here, passing through this point, right? So this is x plus y is equal to 3a. Now, how shall we draw the curve? So it's a node. So it's a double point. So the shape of a double point is like this. Right? Then this branch will go like this, will extend like this. And this branch will go like this. Right? So this is how we draw the Folium of Descartes, x cube plus y cube equal to 3axy. Right? So I hope the point SOAP is helping you to trace any curve, right? So this is how we are going to trace the curve. I hope you understood it, and thank you so much for listening to me. Believe in yourself and you will definitely do it. So do watch my next video to check the next curve, and have a nice day.